If the product of two slope is equal to -1, then it always indicates the perpendicular line parallel to x-axis. Depending upon tan theta, whether it is positive or negative, theta changes to acute or obtuse, and hence phi also changes to obtuse and acute. So even theta is also equal to 0 between any two lines, which means they are parallel to x-axis and hence they are parallel to each other. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to learn angle between the two lines. So when we talk about lines in a plane, so there may be many lines which are either intersecting or parallel to each other. And when I talk about the parallel lines, we know that angle between them is always equal to 0. But when we say intersecting lines, so it may be any angle whose value will be vertically opposite to each other and they are supplementary when it comes to adjacent lines. So when any line intersect, so we know that one line will act as a ray to another line. So it creates a supplementary angle. So if this is theta, then obviously the other one will be 180 minus theta. Same way, so here this becomes theta and this is equal to 180 minus theta. Now we are going to find the angle between the two lines using the concept of slopes. So derive an expression for the angle between two lines with slope m1 and m2. So this is a very important derivation under the chapter straight lines. Now here consider two lines L1 and L2. So here I have taken a coordinate axis, x-axis and y-axis. I am taking the line L1 and line L2 whose angle of inclination is alpha 1 and alpha 2 respectively. Now here we can clearly see line L1 and L2 is intersecting at the given point. So I have taken one angle as theta and the other angle as phi. So now we are going to find out the value of theta. So how to find the value of theta whenever two lines are intersecting with an inclination alpha 1 and alpha 2. So you can clearly say here alpha 1 and alpha 2 angle are completely different. So let M1 and M2 denote the slope of the line. So let M1 is equal to tan alpha 1 and M2 is equal to tan alpha 2. So that is, these are the slopes of the line. Now I need to find out the value of theta here. So we know that when any two lines intersect each other, they always form a vertically opposite angle, making adjacent angle is equal to 180 degree. So here from the figure you can see theta plus phi is always equal to 180 degree. They also creates vertically opposite angle and hence from the figure we can see theta is equal to alpha 2 minus alpha 1. Now I'll apply tan on both sides. So then tan theta is equal to tan of alpha 2 minus alpha 1. So using tan A minus B formula, what is tan A minus B? Tan A minus B is tan A minus tan B divided by 1 plus tan A tan B. So using this formula here in the equation 1, we can write this as tan theta is equal to tan alpha 2 minus tan alpha 1 whole divided by 1 plus tan alpha 2 tan alpha 1. Now from the observation in the given data, tan alpha 1 can be written as m1, tan alpha 2 can be written as m2. So therefore here tan theta is equal to m2 minus m1 divided by 1 plus m1 m2. So provided here the denominator cannot be equal to 0. That is 1 plus m1 m2 cannot be equal to 0, which means m1 into m2 cannot be equal to minus 1. So that means the product of the two slope cannot be equal to minus 1. So what does it suggest? So clearly you can see tan theta if the denominator becomes 0, it becomes non-defined or not defined form or undefined form, which means when tan theta becomes a value as an infinity, 1 by 0 form or an undefined form, only when the line is perpendicular to x-axis. So here m1, m2 not equal to -1 represent we are calculating the angle between two non-vertical lines. So a denominator cannot become 0 here. So thus this is the formula to find out the angle between any two lines. Now here there arises two such cases. We have found theta, but what about 180 minus theta? Also we need to find out what type of theta, whether theta is acute or obtuse. So now case 1 here. So if tan theta value, after using this formula m2 minus m1 by 1 plus m1 m2, if this is positive, which means greater than 0, obviously theta lies in first quadrant. So when I say angle in any first quadrant, theta always lies between 0 to 90 degree. So any angle between 0 to 90 degree will implies theta as acute angle. Now from the figure, here we have theta plus phi is equal to 180 degree. So if I want phi, then it is 180 minus theta. So what happens to phi here? Then phi becomes obtuse. Now next is case 2. Now suppose tan theta value is less than 0. So tan theta value less than 0 means it is negative. So whenever tan theta becomes negative, the angle theta lies in second quadrant. So second quadrant or second quadrant angle we can say. So when theta is negative or tan theta is negative, then it implies theta is an obtuse angle. So here we can say theta and phi both lies in first quadrant, but here I am telling you whenever theta becomes negative, it becomes a second quadrant angle. So any angle in the second quadrant is nothing but their obtuse angle. So therefore theta becomes obtuse whenever tan theta is negative. Thus we can say phi will be equal to acute angle. So depending upon tan theta, whether it is positive or negative, theta changes to acute or obtuse, and hence phi also changes to obtuse and acute. So thus, in both the cases, the formula can be used with the help of modulus m2 minus m1 whole divided by 1 plus m1 m2. So here the condition 1 plus m1 m2 cannot be equal to 0, and hence this is the required standard formula to calculate angle between any two lines. So once again, I am taking two lines, line L1 and L2, whose inclinations are alpha 1 and alpha 2. The slope of them is given by m1 is equal to tan alpha 1, m2 is equal to tan alpha 2. And here, from the figure, two lines are intersecting each other and hence they form a vertically opposite angle, forming two adjacent angles, theta and phi. Theta and phi value is equal to 180 degree. And from the figure we can write theta is equal to alpha 2 minus alpha 1. If I apply tan on both sides, then tan theta is equal to tan alpha 1 minus alpha 2. So on the right hand side, we can use the formula of tan A minus B. And when we use the formula of tan A minus B, the equation reduces to tan theta is equal to m2 minus m1 divided by 1 plus m1 m2, provided the denominator cannot be equal to 0 or the product of two slopes cannot be equal to minus 1. If the product of two slope is equal to minus 1, then it always indicates the perpendicular line parallel to x-axis. But we always define the slope for non-vertical lines. Now, if this is the formula, there arises two cases. So, what is it? If tan theta is positive, then theta is a first quadrant angle. That is, theta lies between 0 to 90 degree, which means theta is acute. So, obviously, 180 minus theta makes phi as obtuse angle. Now, if theta is negative, then it gives a second quadrant angle because tan is negative in second quadrant. So, therefore, theta takes the values of second quadrant angle. So when I say second quadrant angle, it lies between 90 to 180 and hence theta is obtuse, which makes phi as acute. So observing these two cases, the formula tan theta can be substituted with the help of modulus as modulus of m2 minus m1 divided by 1 plus m1 m2, provided the denominator cannot be equal to 0. And this is the expression to find the angle between any two lines. So after all these observations, we see here if two lines are parallel to each other, m1 is equal to m2 because theta is equal to 0 degree. Now consider two lines here which are parallel to each other. So we know that if these two lines are parallel, then angle of inclination, so let this be alpha 1 and let this be alpha 2. Alpha 1 and alpha 2 are also same, and when I say alpha 1 and alpha 2 along the positive direction of x-axis is same, if the inclination is same, then the slope m1 will be equal to m2 because m1 is tan alpha 1, which is same as tan alpha 2. So in such cases, we say the two lines are parallel to each other. And if we arise in such cases where one line is parallel to x-axis and another line is parallel to x-axis. So let this be line 1, let this be line L2. Now we know that L1 is not making any inclination with x-axis. So therefore, here the slope m1 is 0. Which means alpha 1 is 0, inclination is 0. And here also inclination is 0, so m2 is 0. So even theta is also equal to 0 between any two lines, which means they are parallel to x-axis and hence they are parallel to each other. And here we can say, other than that, if we consider any two parallel lines or more than two parallel lines whose inclinations are alpha 1 and alpha 2 along the positive direction of x-axis, they make a pair of corresponding angles. Corresponding angles are equal and hence the slopes become equal. So thus we can conclude that if two lines are parallel, then their slopes are equal. Or if the slopes are equal, we can say the two lines are parallel. The second point is if two lines are perpendicular to each other, the product of their slope is equal to -1 because theta is equal to 90 degree. So if we consider two perpendicular lines here, so let me consider this as x-axis and this as y-axis. So let this be line L1, which is perpendicular to line L2. See, angle between them is 90 degree. And let this be alpha 2 and this is alpha 1. So if alpha 1 is the inclination and alpha 2 is the inclination of line L2, then obviously slope m1 is equal to tan alpha 1 and slope L2 is equal to tan alpha 2. In such cases, the angle between them is equal to tan theta is equal to 90 degree. So whenever we say tan theta is equal to 90 degree, then m1 into m2 will be equal to -1 from the expression above. So this cannot be equal to 0. What does it means? Your m1 and m2 cannot be equal to -1. If they are equal to -1, then these two lines are perpendicular to each other. So therefore, for perpendicular lines, the product of the two slope is equal to -1. The next thing is, if a line parallel to x-axis, then the equation of line is y is equal to k. If a line parallel to y-axis, then the equation of line is x is equal to k. So depending upon the intersection with respect to the coordinate axis. Now if here we are taking a line, we know the equation of x-axis is y is equal to 0. Any line which is at a distance of k from the x-axis and parallel to it, then obviously we can write the equation as y is equal to k. So if it lies down somewhere here with some distance b, but here we'll write y is equal to -b because the coordinate here is minus. And similarly, any line which is parallel to y-axis. So let me consider this one, which is at a distance a. The distance is a. but the coordinate is 0, minus a. In such case, the equation is x is equal to minus a. Suppose if it lies here, whose distance is c, then the coordinate here is c, 0. So in such case, x is equal to c. So here interchange the coordinate because we are talking about the x-axis. So the distance is positive. Here the distance is a, but it cuts the y-axis or x-axis at minus a, and hence the equation becomes x is equal to minus a here, and here x is equal to c. So thus, any line parallel to x-axis will have an equation with y is equal to k. Any line parallel to y-axis will have an equation x is equal to k. So k may be positive or negative depending upon the positive side or negative side of the coordinate axis. Every linear equation of two variable represent a line. Example, ax plus by plus c is equal to 0. So this is a general form of linear equation with the two variables, that is x and y. What do you mean by linear? A linear is nothing but the power of the variable is equal to 1. Then only we say it as a linear polynomial or linear equation. So this equation always represents the equation of a straight line provided a, b are not equal to 0. They are non-zero constants. Now here, if ax plus by plus c is equal to 0 represents a straight line, then there is another way of representing a slope m that can be written as minus a by b. So this is the shortcut formula to remember the slope of a line whenever it is in the linear equation. So here a and b are non-zero constants. Next we will take up a problem. Find the angle between the line root 3x plus y is equal to 1 and x plus root 3y is equal to 1. So you can see here, this is in the form of a linear equation, ax plus by equals c. I already told you the slope m can be written in the form of minus a by b. So therefore, let me consider this as line L1 and this as line L2. Then the slope m1 is written in the form of minus a is root 3 by b, 1, which is equal to minus root 3. And slope m2 is minus a value is 1, b value is root 3. So it is minus 1 by root 3. We know the formula, that is tan theta is equal to m2 minus m1 divided by 1 plus m1 m2 under the modulus. So this is equal to m2 is minus 1 by root 3, minus of minus root 3 becomes plus root 3 whole divided by 1 plus minus root 3 divided by minus 1 by root 3. So here root 3 cancels. So solving this, tan theta is equal to minus 1 plus root 3 into root 3 becomes 3 divided by root 3 whole divided by, we have minus 1 into minus 1 which becomes plus 1, 1 plus 1 is 2. So 2 under the modulus. So now this becomes 2 by root 3 divided by 2. So cancels 1 by root 3. Now if you remove the modulus, then tan theta can be written as plus or minus 1 by root 3. We will take two angles here. Tan theta is equal to plus 1 by root 3 and tan theta is equal to minus 1 by root 3. So whenever tan theta is positive, theta will be acute, and whenever theta is negative, theta will be obtuse. So hence, here this can be written as tan theta. The value of 1 by root 3 under tan is tan 30 degree. Or we can say pi by 6. So therefore, theta is equal to 30 degree. Since tan theta is positive, angle must be acute. So when I am talking about the obtuse angle, obviously here this should be lies in the second quadrant, and hence here minus root 3 can be written as tan of 180 minus 30 degree. Because we know this can be written as minus tan 30 degree. And since we have minus, it should take the second quadrant angle. That's why I'm written it as 180 minus 30. So now tan theta is equal to tan 150 degree. So therefore, theta is equal to 150 degree. So the angle between two lines is one is 30 degree and one is 150 degree. Because when I see the intersection of two lines here, if this is 30 degree, then the other supplementary angle must be 150 degree. So therefore, both angles are found here. Next one. Without using the Pythagoras theorem, show that the points 4, 4, 3, 5 and -1, -1 are the vertices of the right angle triangle. So how, whenever 3 points are given, how to say that they form a vertices of right angle triangle? So let us join those 3 line segment. If angle between any two lines is equal to 90 degree, then we can say if this is M1 and M2, slopes I'm writing M3. So we know the condition, if the product of two slopes is equal to -1, then angle between them is 90 degree. So if we show that the product of any two slopes is equal to -1, we can clearly say obviously there is a right angle formation between the line segments joining the vertices, and hence it forms the right angle triangle. Now let us find the slopes here. So whenever 2 points are given, we have a formula for a slope that m is equal to y2 minus y1 divided by x2 minus x1. So let me consider the slope m1 with respect to point 4, 4 and 3, 5. Then we'll get 5 minus 4 divided by 3 minus 4, which is equal to -1. We'll take slope m2 with respect to the point 3, 5 and -1, -1. So -1 minus 5 -1 minus 3 minus 6 by -4, which is equal to 3 by 2. We'll calculate the slopes with respect to the point 4, 4 and -1, -1. So -1 minus 4 -1 minus 4 minus 5 by -5 cancels. This is equal to 1. Now here clearly M1, M3 is equal to -1. So if the product of two slopes is equal to -1, so this indicates here theta between them is equal to 90 degree. So therefore the points 4, 4, 3, 5 and -1, -1 forms or are the vertices of right angle triangle. So here in this session, the points to remember this: angle between two lines, tan theta can be written as m2 minus m1 divided by 1 plus m1 m2. So this is the first point. And the next thing is two lines are parallel. So two lines are parallel if and only if their slopes are equal. So vice versa, if slopes are equal, then the two lines are parallel. Similarly, two lines are perpendicular if and only if the product of their slopes is equal to -1. Similarly, if the product of their slopes are -1, then the two lines are perpendicular to each other. So I'll meet you in the next session with a new concept. Until then, keep watching, keep learning and keep exploring. Thank you.